Hello and welcome to the 2024 recorded version of our basic Skywarn spotter training class. I am Brian Howell. I'm a meteorologist here at the forecast office and I'll be presenting this class today. I'm originally from the southwest Chicago suburbs, and before I came to the office I started out as a broadcast meteorologist doing radio reports across the country, and then I moved over to private forecasting and was an energy and transportation sector meteorologist for about 7 years, and I did some sporting event type forecasting in there as well. Then I left meteorology for a couple years, got an IT degree, and then I've been here at the NWS Duluth office for about 7.5 years now. Outside of the office, I'm really interested in trains, model railroads, and music. I play the tuba in a couple bands here in town. And I'm a volunteer down at the North Shore Scenic Railroad. I'm an engineer, so if you're ever out and about and you see the train going by, give a wave. It might be me. In terms of meteorology, I've had a strong interest in it since the 1990 Plainfield F5 tornado, where I was only about 5 miles away from it. And that kind of sparked my interest in meteorology, and now I'm here today. So as we get ready here, grab a writing utensil and paper, or have a document open you can take some notes on. But most importantly, there's going to be 3 code words that are going to be presented in this presentation. Write these down and have them on hand, because when you go to register after taking the class, you're going to need those 3 code words to progress through the form. And if you don't want to register, that's fine. It's voluntary. You don't have to. But it's a way for us to be able to contact you in case a storm passes over you and we have everyone plotted on a map, and then we can see where the storm is, where the spotters are, and give those people a call that most likely are seeing things. So it's just a way for us to gather reports. So we'll kick things right off with a tornado video, because honestly, isn't that why we're all here? This is from an event in December a few years ago. Skip Talbot grabbed this down outside Beardstown, Illinois, and just really great video. Skip does a real good job getting into position and getting some great video. This is sped up. It's not real time, but just great structure. Not a lot of precip falling with this storm, so we had a really good view of the tornado. Kind of see some of those rain curtains wrapping around the back, but just a really awesome video. The whole storm is rotating, got those striations up there. And if you don't understand anything I just said, well, stay tuned. We're going to cover a lot of this here as we progress through the presentation. And now you've seen your tornado video, we'll see you next year. No, we hope you stick around here. So just a little bit about our office to get started. We are located here in Duluth, Minnesota, right up by the airport. There's about 20 of us working here at the office, with 16 of those being meteorologists, and we serve northeastern Minnesota and northwestern Wisconsin, and a good portion of western Lake Superior. We are always open. There's at least 2 people here all the time. Holidays, overnights, we're here. We're one of 122 local weather forecast offices across the country, and we produce forecasts and warnings for the public, as well as some of our specific partners in the aviation sectors, fire weather, marine, western Lake Superior, shipping interest, and the transportation sectors. And we're here, besides making those forecasts and warnings, to help decision makers with weather decisions. I'm recording this here in the first week of April. Last week we had a major system affect the region, so we were in contact with a lot of emergency managers, school superintendents, to help make decisions, especially for those school superintendents, whether school can be open or not. Can people make it to the building? Can buses make it through the snow? We're here to help those decisions get made. So here's a look at our office from a few years ago. This was a severe weather day. This was a day when it's all hands on deck, and every workstation was filled this day. And we were all here ready to warn the public of severe weather. So what exactly is a spotter? Well, a spotter is someone who observes the weather and then communicates what they see to the National Weather Service. And a spotter is someone who definitely stays safe and plays a critical role in helping the National Weather Service and local officials. And anyone can be a spotter. Anyone can take this training and send reports to us. There's no age limitation, and if you just have an interest in weather, great. If you have a friend who might be interested or a family member, let them know about our training. We've got multiple classes coming up here over the next 2 months, April and May. We've got some virtual options, and then this recorded version is always going to be available on our website. A spotter is not a weather expert. You don't need a degree to be a spotter. Or you don't need any special experience. You take this class and you can spot. A spotter is not a storm chaser. While almost all chasers are spotters, we don't officially condone storm chasing. It is a very difficult and dangerous activity. We're not teaching you the skills to be able to do that. If you are interested in that, there are tour groups that you can go out with. There's some schools that offer storm chasing classes that are open to the public. So if that's something you're interested in, we would recommend one of those avenues, but this is not a class to teach you how to storm chase. A spotter is not above the law. Don't try to use your certificate to get out of a speeding ticket or get around some sort of police barrier. That ticket's not going to mean anything, and they're going to make you turn around. And a spotter is not immune to the laws of physics. Just because you have this training doesn't mean you're not going to get blown away by the storm. No, that definitely will still happen. So you might think, why do we even need spotters anymore? We've got all these great tools available to us. We've got radar, we've got satellites, we've got computer models. So what role does a spotter serve at this point? Well, when we're issuing warnings, we're relying on 4 different things here: the radar, the environment, experience, and those spotter reports. If we can get 3 out of 4 of these, we're feeling pretty good about those warnings. If we can get all 4, that's awesome. So starting first with radar, we have pretty good radar coverage here from the Duluth office. We are fortunate to have an extra cut on our radar. We can go down a little lower than most radars, so that means we can see further away. But still, the further you get away from the radar, the higher that radar beam is up in the air. So in terms of severe weather, we're really interested in seeing what's going on, the lowest couple hundred feet of the atmosphere, right at the surface. And that's exactly what the radar can't see. So that's essential to have spotters to give us that ground truth of what's going on. Second thing, we're basing our decisions on the environment. Well, what does that include? Surface observations, radiosonde data from weather balloons. That gives us a vertical profile of the atmosphere. Satellite imageries. We've come so far with satellite technology over the last 10 to 15 years. During severe weather events, we can get satellite images as fast as once per minute. And that can really help our warning abilities by seeing what the top of the storm is doing. There's correlations with tornado genesis with what's going on at the top of the storm. We've got more computer models than we can possibly look at. There are so many models, and some do really great, some not so great for severe weather, but it's really a great tool that has expanded over the last few years. And hand analysis. We still print out maps and we still draw on them to get a picture of what the atmosphere is doing, what the surface conditions are that can help us find boundaries or other features that can lead to potential severe weather development. And then we also look at experience. We've got a lot of experience here at the office. Each person that works here gets over 120 hours of radar and warning training. That's both virtual and in person. We go down, every new employee goes down to Norman, Oklahoma for a week and does an intense training session where they're issuing warnings in a simulated environment and getting feedback on that. And it's a really great experience and really helps us get that knowledge to be able to issue those warnings. We're also continually learning. We have hands-on simulator time every year. We do that in the spring, late winter, early spring to get ready for severe weather season. We always have one lead forecaster on shift that's got at least 15 years of experience. And as I said, we're continuously learning from past events. We try to verify all our warnings. and we do training sessions. And for some of our major events, we'll do event reviews where we sit down and we talk about what went well, what didn't go well, and we look at that kind of stuff. So we're always trying to improve what we do. So again, 3 out of 4 of these things, if we can get those, we're feeling pretty good about a warning. All 4, then we know this warning is a good warning. So spotters are essential in that because we need to know what's going on at the surface. And even though we have all these cool tools, they can't really tell us what's going on at the surface. So speaking of that, these are all the storm reports we received last year. Every orange dot was a trained spotter. Every green dot was a CoCoRaHS volunteer. Blue dots were public reports. And gray dots were from various other sources, whether that be law enforcement or as over Lake Superior, those were boats that sent us wind reports. But in total, we issued 5,617 storm reports last year, including 628 of those from trained spotters. And even though we've got these nice surface weather observing systems, only human observers can tell us about hail, wind damage, tornadoes, and flash flooding. Those automated weather observation systems are really good for temperature and winds, but they can't tell us about the other things, which is what we're really interested in. So that's why spotters are so important to the severe weather warning process. So taking a look at last year's severe weather season, it was definitely a down year. We had drought conditions again across much of the area. And if you were in Cass County, unless you were in that far southeastern corner, you didn't have any sort of convective warning last year. And that's incredibly rare. A good chunk of Coochin County didn't have anything. Central St. Louis, it was a pretty quiet year in terms of severe weather. We only issued 6 tornado warnings, 85 severe thunderstorm warnings, 35 special marine warnings. That was a bit more on the higher end of average, and only 6 flash flood warnings. So again, very, very below average year for severe weather. We'll throw up 2022 severe weather season, and aside from a small portion of northern Bayfield County, everybody saw at least one warning last year, or in 22 rather, and many of those places saw quite a few. There are so many overlaid across portions of Cass, Crow Wing, Aitkin, Itasca counties. You can't even see. There's just so many piled on top of each other. So flipping back, you can really get an idea here of how quiet of a severe season it was compared to the year before. So looking again at last year's severe weather season, this is all of our spotter reports overlaid with our warnings. So pretty good. We did have some smaller hail reports out across Cass County that were not a part of warnings, and those are probably maybe 1-inch hail reports or penny-sized hail reports. But this is a really interesting way just to show, that we try to verify all of our warnings. So what is this course going to cover? Well, we're going to look at monitoring the forecast first. That's going to be covering our outlooks, our watches, and our warnings, those kind of things. And then we'll move on to the science of thunderstorms. This is going to be the science, staying safe when you're looking at storms, and then what to report. And then finally, we're going to talk about spotting itself. How do you get, once you see what's going on, how do you get those reports to us? So jumping right in with monitoring the forecast, there's so many different ways to get weather information. Where do you turn to? Well, very good first spot is directly from us and our website, weather.gov/Duluth. We've got graphics on here, hourly forecast, the forecast discussion. So much information is available on our website. Social media feeds. We're on Twitter and Facebook, and those links can be seen there. And then one of my favorite, NOAA Weather Radio. We have great coverage across our area, and I'll talk about that more coming up here in a few moments. And then other sources, local TV and radio stations and their websites and social media. We have a great team of media partners here in northeastern Minnesota and northwest Wisconsin. We work very closely with our partners here in Duluth. We have them at our training, and we've been down to their stations for visits, and we have a really good working relationship with them. And we're very fortunate to have that because that's not the case in all areas. Reliable apps. Unfortunately, we don't have an official weather service or NOAA app. We wish we did, but it's kind of out of our hands right now. So what kind of app can you use? Well, look for ones from well-known companies. Check the reviews. Ask your friends, see what they use. See if they have one that they really like. There's so many of them out there, and some of them, a lot of them are better than others. So you have to find one that works best for you. And some of these apps can alert you to severe weather, but you have to turn the do not disturb mode off to be able to have them wake you up and protect you from potential severe weather events. We'll talk about that more in a few minutes. There's also systems out there provided by your county or tribal areas emergency notification system. And we'll talk about that a little bit more here coming up too. So, starting out the week, let's say, we've got a severe weather risk later in the week. So at the beginning of the week, we're in what's called the outlook phase, a couple days in advance. The two sources of information at that point are going to be from the Storm Prediction Center down in Norman, Oklahoma, and they're going to issue a product called the Convective Outlook. And that's going to look at the thunderstorm potential over the next 1 to 3 days, but they also do a long-range forecast too. That's the next 4 to 8 days. If there's a strong enough signal, they can put that risk of thunderstorms in there. And then from our local office, we have a product called the Hazardous Weather Outlook. But at this point, what you need to be doing is it's kind of the stay tuned period. This is, look at your plans for the rest of the week. Are you going to go out maybe camping later on? You might need to change your plans. This is the time to kind of start thinking about that. Now it's the day of, we're still hopefully 3 to 6 hours out from the actual storms, start to develop. And then at this point, we start to get into the watch phase. And we coordinate with the Storm Prediction Center to develop those watches. The Storm Prediction Center will outline an area they think they need to be in a watch, and then they'll have a conference call with the local offices, and we'll say, hey, this looks good, or maybe we think this area needs to be included as well, so we have a little bit of discussion there, and then after that, the watch will come out. So at this point now, we need to have our plan in place. Okay, we're still going to go have our picnic today, but there's shelter nearby, so if something happens, we can get into that shelter. That kind of thing. Have a plan. So now the storms have developed, and they're now starting to produce severe weather. This is the warning phase. This comes directly from our office. We issue all those warnings. This is the time to act. The time is now to take action. So we'll take a look at all of these things. So one thing that it can be very confusing to people is what's a watch versus a warning. We found that this little analogy here really helps with that. So in a watch, all your ingredients are in place. And when you get to the warning, it's happening now. So in terms of baking a cupcake here, for an example, we've got all our ingredients here. That's the watch. And then as we get closer, we've mixed those ingredients. We've put it in the oven. We now have cupcakes. They're ready to eat. That's a cupcake warning. It's time to eat. It's here. So going back to the outlook phase, this is what the thunderstorm outlooks look like that come from the Storm Prediction Center. These rank the risk for severe storms on a 0 to 5 scale, 0 being just general thunderstorms, no strong or severe storms expected, all the way up to a high risk. And these go out through day 8. In our area, we tend to see about 15 marginal risks per year, and it goes up, or goes down rather, from there. We usually don't see moderate or high up here. So when those do occur, we really need to pay attention. I think it's been since 2008 that the last time there was a high risk in parts of Minnesota. The June 17th, 2010 event, that was only a moderate. We didn't get up to high that day. That was a big severe weather outbreak. But once we're getting into the enhanced moderate high category, we really need to be paying attention. And as we look at that graphic on the right, once it restarts here. So this is 72 hours out before the storm. And then as we move closer to the storm, as the forecast becomes more refined, the risk level goes up and the area becomes more precise. We kind of focus in on that area. So as we start out, flip around here, we have a wide area of enhanced risk. Then that narrows down. And then we see that some of the ingredients are a little bit stronger in western Minnesota, eastern South Dakota, so they went with a moderate risk. And then that expanded as the threat increased as we got closer to the day of the event. So on the local side, we have what's called the Hazardous Weather Outlook. This is a plain English message about the severe weather risk over the next 7 days. We like to call this a one-stop shop. It's simple. If you've only got a couple minutes to look at what the severe weather risk is, this is a great place to find it. We update this at least twice a day, usually early in the morning around 4 a.m. and then again in the afternoon around 4 p.m. This is on our website and plays periodically on Weather Radio. The direct link to this is weather.gov/DLH/HWO. So it's a little more vague if the event is further out in the week. We talk about, okay, there's going to be chances for storms this weekend into next week, and talk about some of the possible modes of severe weather. What kind of threats are we looking for? And in this example, damaging hail, winds, tornadoes, flash flooding, all possible. Once we get to the day of, we get a bit more specific in this product. So in this example, we expect severe storms to develop later this afternoon, most likely after 4 p.m., and last at least into the late evening hours. So we've got a more defined time range there. And then we move on and we describe the region that we're expecting. So the storm should first impact the Brainerd Lakes area. And these storms will be capable of producing tornadoes, damaging winds in excess of 65 miles per hour, large hail, and heavy rain. So we get a lot more focused and specific the closer we get to the event. And then at the bottom of this product is a section that's called the spotter information statement. And this will be, a short 1 to 2 sentence blurb that just says, spotters are not going to be needed today. Spotters will likely be needed tonight or this afternoon. So that's just a one short, quick area to check to see if spotters are going to be needed on a day. So now we've reached the warning, or the watch phase rather. So there's typically 3 types of watches that are issued during the summertime. And the first of that is going to be the Severe Thunderstorm Watch. And for this one, the ingredients are in place for severe thunderstorms that could produce large hail and damaging winds over the next few hours. Some tornadoes are possible, but that's not the main risk. It's large hail and damaging winds. These are the most common, and we tend to get about 3 to 6 of these in the Duluth forecast area per year. For Tornado Watch, still ingredients are in place for severe thunderstorms that could produce large hail and damaging winds, but there's also a greater risk for tornadoes. So that's why we can go a step higher and go to a Tornado Watch. These are pretty rare. We only get 1 to 2 of these per year, if that. And then lastly is the Flash Flood Watch. These are a little more longer in duration, and they tend to come out earlier. And these are for when ingredients are in place for flash flooding in the next 12 to 24 hours. And these tend to be pretty rare too, only about 1 to 3 per year. And our example on the right is from Memorial Day 2022. That's where a lot of our examples come from in this presentation. That was one of the biggest severe weather events in our area over the last few years. So we got a lot of good examples to come out of that. So in this watch, this was issued at 2:30 p.m. and it went until 10 p.m. on Memorial Day and covered a good chunk of Minnesota. And that was a tornado watch. And what ended up happening is those storms down in southeastern South Dakota and then along the Iowa-Nebraska border became strong. And as they moved to the northeast, turned into a bowing segment, and there were multiple embedded tornadoes and a lot of damaging wind that came out of this. And we'll see some more of that here coming up. So now we've reached the warning phase. This is the storms are here. We need to take shelter now. It could be a couple minutes out. It could be already happening. At this point, you need to take shelter. You have minutes at this point. We issue our warnings as polygons. We used to have to issue them as entire counties, but some of these counties in our area are pretty darn big. Take a look at St. Louis County. It's huge. It takes 3.5 hours to drive from Duluth up towards International Falls. And, if we had to issue a warning, 15 years ago for St. Louis County, let's say there's a storm that's coming towards the Duluth area. Well, areas up north by Cabotogama could have bright sunshine, not even get a drop of rain. So, fortunately, as technology has evolved, we've moved to issuing storm-based warnings and can issue those as polygons and really focus in the area that's getting alerted. And again, your reports help us make those warning decisions. So, what is a severe thunderstorm warning? Well, you have to have winds 58 miles per hour or greater and or quarter 1-inch sized hail or larger. And we usually issue about 120 to 150 of these per year. Tornado warnings, a spotter report or radar indication of a tornado. These are pretty rare, only about 5 to 10 per year. And then for those flash flood warnings, we're expecting a flooding threat to life and property within the next 6 hours, and we get about 5 to 10 of those per year. And this is our looking at our example from Memorial Day of 2022. We see that line of storms moving off to the northeast, and those yellow boxes are severe thunderstorm warnings, and the red boxes are tornado warnings. And there's a couple of flood warnings up along the north. We had some flooding issues in the Rainy Lake Basin at that point, and they were going to be exacerbated by this rainfall that was moving in. So, really good example here that shows, these three types of warnings. So here's a look at a storm that moved out of Beltrami County into northern Cass County, and this was back in the summer of 2021. The emergency manager from Beltrami County was out following this storm and relaying us reports because it had a rotating wall cloud on it and it looked like it could potentially drop a tornado. And then he stopped when it reached the county border and moved into our area because Beltrami County is actually over in the Grand Forks forecast area, and he had other duties to attend to once the storm was out of his area. So as that storm moved into our area, we were trying to decide, okay, do we need to go severe thunderstorm warning or do we need a tornado warning on this? And because the emergency manager had been following it, it did have a wall cloud and it wasn't really rotating as much by the time it got to the county border. We hadn't had any tornado reports. It wasn't looking as good on radar as it was before, so we opted to go with a severe thunderstorm warning based on what he was seeing. And then as the storm moved closer to the Leech Lake area over Federal Dam, we've got a report of 1-inch hail out of that. So when we get those reports, that helps us inform those warning decisions. And then we can put that information right into the warning product. So this is an example of the warning that was issued on the right-hand side. This is the text product that comes out. And under the source header, we see trained weather spotters reported quarter-sized hail at 8:25 p.m. in Federal Dam along with a wall cloud. So we take those reports and we can put them right into the warning text because studies have shown if people see that the phenomenon has been reported, it's actually occurring, they're more inclined to take action and get themselves to shelter. So your reports turn out to be very important, not just for the warning process, but helping people know, okay, it's happening. I need to take action. So there's many different ways to receive warnings, and you need to have at least two. So to have some redundancy there to make sure you're getting everything. So the ones that we feel are the best are, NOAA weather radios with the public alert logo. As I said before, we have large coverage across our area, so you should be able to get coverage anywhere in our forecast area. And that includes the boundary waters. We have coverage across the entire wilderness area. So if you're heading out to the boundary waters, take a little battery-powered weather radio. Make sure you have that so you can have an idea of severe weather's coming. Reliable apps with push alerts. The wireless emergency alerts, WIA, those come out for all tornado warnings. Destructive severe thunderstorms, so that's going to be thunderstorms with winds 80 miles per hour or greater or baseball-sized hail or larger. And select flash flood warnings. We only issue those for the high-end flash flood warnings now. It used to be all of them. Now it goes out for just the high-end ones. There's commercial services out there that can send you a text message or call you. And then if your county or tribe has an emergency notification service like Code Red, Everbridge. There's a couple of them out there. Those are usually offered as a free service to the residents of the county if they have one. So you might want to check with them and see if that's something you can sign up for. And all of these are options that can wake you up and allow you to take safety if something happens during the middle of the night. Other ways to get warnings, but they can't wake you up, is your local media, TV, radio stations, websites, most apps, unless they can send out those push alerts. Friends, family, coworkers, social media, that's can't really wake you up unless it's like a family member, living with you. That's a different story. And then outdoor warning sirens. Those are really meant for people taking part in outdoor activities. If you are at home and you're relying on those warning sirens to take shelter, it's not the greatest idea. If it's the middle of summer, it's hot, it's humid, you've got your house closed up, you've got the air conditioning going, you're not going to hear that. And if it's at night and you're sleeping, probably not going to hear it as well. Now, if the tornado siren is right outside your home, that's one thing, but for the most part, those shouldn't be relied upon. So talking a little bit more about weather radio, that's a continuous weather broadcast. That's all it is. It cycles through the forecast and local weather conditions and any watches or warnings that are out there. During thunderstorm events, if there's warnings out, it'll just keep replaying that warning. So you can tune it at any time and you won't have to wait long to hear that information. But if you're considering getting a weather radio, if you don't have one already, look for one with same technology. And that's going to allow you to program it so it only goes off for certain counties. So if you live in the Duluth area, you might not be interested in warnings for, let's say, Bayfield County. Storm's probably already passed you. It's not going to affect you. Doesn't matter. So you can program it so it's just going to alert for, let's say, Carlton or southern St. Louis County to give you some heads up. And that's going to cut down on how often it goes off. And these are usually pretty cheap. You can get small handheld ones for about $20. Maybe, $30-$40 for one of the ones like that white one there in the center. And, those are really good. The one in the white one there in the center is what I have. We've got one of those here in the office that we use for testing, making sure our warnings are going out. And they work. They do a good job. I like to call them the smoke detectors of severe weather. I'd be happy if every house was required to have one, just like smoke detectors. And I mentioned before about those wireless emergency alerts, the WEAs. And those are sent for tornado warnings, the destructive severe thunderstorm warnings, high-end flash flood warnings, and some snow squall warnings. We have forecaster discretion on that now for snow squall warnings. Originally, it was all of them. Now it's a forecaster selected option if that goes off or not. But the WEA, it's free, it's built into your smartphone, and it works as long as you have a cell signal. It should be activated by default when you get it. The current generation of this technology, I think it's got 80% of phones out there are at the current generation, and that can get your location down to 1/10 of a mile. So it's only going to go off if you're within that warning polygon. So if it goes off, you're affected. It's not like before where everybody in range of the cell tower would get that alert. Now it's just if you are geolocated within that warning polygon. And make sure you have it turned on. Sometimes it can get turned off, but it should be on by default. And you have to go into your settings to be able to do that. And there's a couple ways to do that there for iPhone and Android. And as I said before, there are 3 code words to write down. We'll toss out the first one here, and that's going to be tornado. First code word is tornado. So moving now, we'll look at the science of thunderstorms. We've got a list of words there on the right. Some of them look like they could be a different language. But by the end of this section, you'll have a pretty good idea of what all those mean. So what do we need for thunderstorms? A good acronym for that is SLIM, with S standing for wind shear, L for lift, I instability, M for moisture. Wind shear is the winds from the surface to the top of the troposphere. And that's what's going to help storms become organized. We need differing wind speeds, differing wind directions to get those storms to rotate. And that's what's going to help us get those strong to severe storms. Lift is some sort of mechanism for storms to develop. A lot of times this is a front or leftover boundaries from other storms that happen, let's say last night or earlier in the day. That gets that air, it forces that air to start rising. And then we've got instability. Hot, humid environment with dry conditions aloft, cool and cool is the ingredients we need for instability. This is the fuel of the storms if they are developed. So once that parcel of air, we'll call it, so imagine a piece of air, it gets lifted up by some sort of forcing mechanism, then that instability takes over and keeps that air rising, and that's what gives us our cloud development, which then develops into storms. And then obviously for storms, we're going to need moisture. We need rich, low-level moisture to help get those storms going. We measure that with the dew point. Higher dew points mean there is more moisture for storms. And there's other things that go into storms as well. These are just the four major ones. And if you're interested in more, we have our advanced classes coming up. We've got 2 live virtual ones. So be sure to sign up for one of those if you'd like more information. So we ask that you take all watches and warnings seriously. Just, if we've got similar ingredients, that doesn't mean we're going to have the same outcome every time. It could be different. Take, for example, here, we've got our butter, oil, flour, sugar, baking soda, eggs, some vanilla, and you could make multiple things from that. It could be cupcakes, it could be cookies, and if maybe you're not the best baker or something happens, you could get nothing at all. So just because we have all these ingredients in place doesn't mean you're going to have a tornado or you're going to have a severe thunderstorm warning. Many different things can happen. But the point is to take all watches and warnings seriously. We classify thunderstorms into 3 main types. We've got single cell storms, multicellular storms, and supercells. We'll take a closer look at each one of these. For single cell storms, these are our common summer afternoon thunderstorms. They develop, they last maybe 45 minutes to an hour, drop some rain. Not a problem. Don't really produce severe weather. If they do, it's usually smaller sized hail, peas up to about quarter size. Maybe some gusty winds in them, maybe later on in the storm cycle as it's falling apart. Usually less than 70 miles per hour. You can get brief, weak tornadoes, but not usually. And maybe some quick, heavy rainfall. In our example here on the right, this was from August of 2020. I was the warning forecaster this day. We had some storms coming across the border, and they looked like they could produce maybe some quarter-sized hail. So I went out and drew up a warning and issued it at this point, and then we had a couple 1-inch hail reports and even one up to 1.25 inches up by Crane Lake. And then the storm kind of fell apart for a little bit, and then it started to ramp up again just a little bit and ended up producing a little bit more hail. It was only about to the size of nickels. But this was one of those events. The storms didn't last very long. They were kind of up and down, pulsy. They weren't organized, and we need that organization to get our long-lived severe threats. And we get our multicellular storms. These are what we see up here most often, and usually they're severe. These can be long-lasting, on the order of 45 minutes to 8 hours or more as these areas of storms cross across multiple states. Large hail is possible out of these, but in these events, damaging winds are going to be your primary threat. You can get brief tornadoes in here that can be weak or strong, and you can get extensive flash flooding out of these if they orient themselves just right and remain over the same area for long periods of time. These types of storms go by many different names: squall line, derecho, bow echo. Some of the more advanced terms for these that we cover in our advanced class: mesoscale convective system, mesoscale convective complex, quasi-linear convective systems. Basically, they all mean the same thing. It's a line of intense thunderstorms, which is what we had on Memorial Day of 2022. And there's a radar overview on the right showing the warnings that were issued. The watch boxes are there, along with all the warnings that were issued. So we had this line of storms with embedded Boeing segments pushing northeast across northeastern and eastern Minnesota. While it was mainly wind damage, there were tornadoes embedded within there as well. And with these types of storms, you'll get a lot of times you'll get shelf clouds out in front of them. That's that picture there in the middle where it'll just be a line of clouds that just stretches from horizon to horizon. Shelf clouds themselves aren't indicative of severe weather. They're just a natural byproduct of this type of storm. And we'll talk a little bit more about that coming up. The last storm is the supercell. These are very rare. But when they do develop, they're more than likely severe. These are storms. They're very strong. They can last for multiple hours. These are going to produce your biggest hail. They can produce damaging winds. And these are going to produce the most violent tornadoes. And flash flooding is possible with these as well. These type of storms can be very prolific rain producers. And if they're slow moving, that can be a recipe for flash flooding. But in our example here of the supercell, this is the updraft area of the storm. Most of your rain is falling off to the right-hand side of the picture, but this is where the severe weather is going to occur, is right here in the center of the picture. That's where the possible tornado is. We see a wall cloud in there and maybe a little bit of rain in the background, but this is right here is hail, tornado. This is what we're looking for. And this whole storm is rotating. You can see those striations there in the mid-level in the middle of the picture as that whole storm is rotating. But even though supercells are the rarest type of storm, they produce a disproportionate amount of severe weather. So if this is what we're expecting for the day, they're probably going to produce a lot of severe weather. We don't get them up here a lot, but they can still happen. So we need to take these seriously. All thunderstorms go through a life cycle. The first step is the towering cumulus stage. At this point, the storm's just getting organized. We're all updraft at this point. The air is rising. We're not raining yet, and the storm's just getting organized. We're not expecting severe weather at this point. Everything's moving up. Nothing's coming down, and we need the stuff coming down to be able to have severe weather. And as that air rises, it reaches the top of the lowest level of the atmosphere, and then it starts to spread out. And then as that cools down, it starts raining. So we've got updraft at this point, we've got downdraft, and when those are in balance, then we start to get the potential for severe weather. In the downdraft area, we'll have hail, heavy rainfall, those damaging winds, and then back in the updraft area on the right in this example, that could be the potential tornado area. So the mature stage of thunderstorms is where we're expecting most of that severe weather. And then later on in the storm life cycle, that updraft gets cut off. We don't have any more rising air, so the storm just drops everything and starts dissipating. There still could be some severe weather at this point as the storm just dumps out everything that's held aloft, so we can get maybe some damaging wind gusts at this point as all that stuff just drops out of the sky and hits the ground and spreads out. So the two main components of a thunderstorm are going to be your updraft and your downdraft. And we'll go into a little bit of detail here now. So the updraft area, to find that, we need to look for the rain-free base. When storms develop, they're going to start first with that updraft. And as that air rises, it cools, and then some of the water vapor in there condenses, and that's what actually forms the cloud. And to find the updraft area, you look for the rain-free base of the thunderstorm. So the area we're talking about is the area here on the right. And in this presentation, all of our updraft areas are going to be shown by the red arrows, and our downdraft areas shown by the blue arrows. So that rain-free base is going to be underneath there, which those yellowish orange arrows are pointing at. So why do we need to find the rain-free base? Well, that's where the most important things are going to happen that we're looking for. The wall clouds, funnel clouds, tornadoes. So that's why we need to find that rain-free base. And not all storms are going to have a clear rain-free base. Sometimes, as in heavier supercells, heavier thunderstorms, it can actually pull that rain around the updraft area and obscure it. So sometimes it's not going to be this ideal presentation like we see in the pictures here. There's our updraft area under the wall cloud and the rain-free area, and that downdraft area preceding it in front. So in this supercell example, we've got our rain-free base area pretty much in the middle of the picture. And on the right-hand side, we see the dark area. That's going to be where all the rain is occurring and some of the hail. But in this area, it's probably not raining a whole lot in the foreground of the middle. It is in the background. We can see that darker area. But this is our rain-free base area. And one thing to realize, most storms are not going to be this easy. This is an idealized example, especially up in our area for reasons we're going to talk about in a moment. We're not going to be able to see all these features. But right there in the middle, there's our updraft area and our downdraft. So we need to look for that wall cloud because a lot of times that's going to be the precursor to a tornado. Not necessarily, but a lot of the times, yes. That wall cloud is always going to be located under the rain-free base. But if you see some sort of lowering elsewhere, not a wall cloud. So if you do see a wall cloud, you need to watch for persistent rotation. And just because one's there doesn't mean it's going to rotate. They might be rotating slowly, fast. So you got to keep watching it. And that rotation must be persistent. If you've just got a wall cloud that's just hanging there, not rotating, just moving along with the storm, probably not going to produce a tornado. But if it's rotating and it's obvious rotation, that could be, we could have a tornado here pretty shortly. So definitely we need to see if it's rotating and how fast or how slow it's rotating is what's important. So we're taking a look at an example of a wall cloud here. This is from back in 2020 in Bertha, Minnesota. So this storm is moving from right to left. We've got our updraft area in the center, rain-free base in the center of the photo as well. And we can see those updraft area. We got the billowing clouds on the right-hand side. We start to see the anvil developing at the top of the frame, but we're looking at the updraft area. We know this. It's our rain-free base area. So this is where we want to focus to see if there's going to be any wall cloud or tornado development. So here's another example of a storm trying to develop a wall cloud. This is sped up a little bit so you can see it. It's not a really well organized or defined wall cloud, but we can definitely tell there's rotation occurring in this storm. We can see the clouds moving left to right in the foreground and right to left in the background. So, and there's no rain here. You can kind of see some rain shafts circling around there. But this is our rain-free updraft base. This is where we need to be focusing on for any potential tornado development. And up here in northeastern Minnesota, northwestern Wisconsin, we have a lot of trees. So this is a little bit north of Grand Rapids. And this was a supercell that was moving across the area from west to east. And I don't know what's going on back there. I mean, it looks like it could be a wall cloud, but with those trees in the air and in front of it, maybe there's a tornado under there. We just don't know. So it's very difficult to be able to see these features in our area because there's just so many trees around and so many hills. So what is a funnel cloud? Well, it's just a rotating funnel extending from the base of a storm. And the key differentiator between a funnel cloud and a tornado is the funnel cloud is not touching the ground. The funnel cloud is essentially the beginning of a tornado, but not every funnel cloud becomes a tornado. They can come in all colors, shapes, and sizes. And you might not be able to confirm the difference between a funnel and a tornado, especially if you're in the woods. You have to see what's going on at the surface. If you're seeing spin at the surface, that's a tornado. The column of air is invisible, but it is a tornado because we're seeing that circulation on the ground. This is an example from 2019. We have a funnel cloud there. It's rotating, but we can't see what's going on at the ground because there's trees in the way. So what happens when the funnel cloud reaches the ground? Well, it's a tornado. Definition of a tornado is a violently rotating column of air in contact with the ground and the cloud base. Now, notice in here it says nothing about visual appearance. Technically, a tornado can be invisible. It becomes visible by debris that it picks up, dirt, other types of debris, and also by condensation of that water vapor with cooler air to make it become visible. So technically, you can't have a visible tornado. It might not be visible at all times. So that's why it's very important to be able to see the ground to see if there's debris starting to swirl down there. But tornadoes can produce violent damage in small localized areas. They can be different sizes and shapes. They're not always going to look the same. They can look pretty small at the beginning, and they can, as they get stronger, they can become wider. And then as they start to diminish, they can become really small and look like a tail and just kind of, we call it a snake. It can, loop around before it dissipates. So they're always changing. They're not always going to look the same. And they don't just move in one direction. They can make turns. They can loop around. So just because you might be safe at the time, it can change direction. So you got to be aware of that. A waterspout is a type of tornado that can form from both thunderstorms and in fair weather conditions. Not all tornadoes are not all waterspouts are tornadoes. There's different mechanisms. If it's a true waterspout, it's going to happen with maybe a developing shower or just some existing spin in the atmosphere. If it's not connected with like a supercell thunderstorm, then it's not going to be as strong. But that's getting into semantics and probably something more in line with one of our advanced classes. But either way, they need to be taken seriously if it's a waterspout or a tornado because they can both produce damage. Starting first, here's an example of a tornado that was in the Garrison, Minnesota area east of Brainerd back in July of 2020. And this person was able to get a good view of this storm. This is actually from behind the storm. He's looking towards the east. So we've got our rain going on in the background. The tornado is moving away from him at this point. But this really demonstrates, we can't see what's going on down at the ground. So at this point, if you were the person seeing this, you could, give us a call and say, hey, I've definitely got a rotating funnel cloud, but I can't see the ground. I don't know if this is on the ground or not. But this was, and it did hit a home, caused some damage, but there were no injuries or anything with this storm. So we're looking at our updraft area in the middle. Tornado is right underneath that. We can see some more of that rain off to the left-hand side. We've got a tail coming out, pulling in that cool, moist air up into that updraft, and then the tornado is right under there. So maybe not the greatest tornado video, but up in our area, this is what they're going to look like a lot of times. And this is a really good video for teaching purposes. And as it keeps playing here, it's changed. It was, kind of a triangle cone shaped at the beginning. Now it's starting to widen out a little bit, maybe more of a stovepipe type of appearance, kind of twisting around a little bit there. So they're not always going to look the same. So here maybe it weakened a little bit, or it's not picking up anything. So we're not seeing a connection to the ground there anymore. Going back to our Memorial Day of 22 event, this is a tornado within that line of embedded thunderstorms. And these are almost impossible to see. These people just happen to be in the right place at the right time. We can see a little bit of rotation there at the surface, but there is just so much rain and wind going on in these events. It's just almost impossible to see. I'll let this run through again for you. So definite lowering there. We start to see some rotation. It's not very clear, but that's the point. These are so difficult to see. You have to be in just the right place, and unfortunately, that's where the damage is occurring. So, this is those lines of thunderstorms. Sometimes we'll say QLCS. This is those type of events. So we'll take a little bit of a quiz here. What are we looking at here? Is this a tornado? We've definitely got a funnel cloud there, but is that reaching the ground? Yeah, it's a little difficult to see, but there is some debris that's starting to get picked up there. So this would be a tornado. And here's another one. We've got trees in the front here. We can't tell if this is touching the ground, but we'll keep watching it here. This is the same storm, just a couple seconds later, maybe a little bit more of a wide view, but we're looking at our rain-free base area. We see the precipitation on the left. So we're looking in the right area. We definitely have a lowering there, and it's come out from behind the trees, and it looks like there's something going on down there. And then we zoom back in, and yeah, we can see that is a tornado. It's on the ground. It's picking up dirt from that farm field. And now it's becoming a little bit stronger. It's changed shape. It's more of a stovepipe appearance now. So just because the tornado looks one way at one point, it's going to change. So keep an eye on it. So we rate tornadoes based on the damage they produce. And then we correlate wind speeds to that. So just because we have a measured wind speed from a tornado, we can't assign a rating based on that because we use the enhanced Fujita scale. That is a damage scale. Fortunately, most tornadoes are considered weak, EF0, EF1, and that's going to be minor damage. Maybe some trees snapped, some roofing material lost, or maybe in the case of modular homes, overturned or badly damaged. But for the most part, it's not major damage. Once we get up to EF2 and higher, then we start getting progressively worse in terms of damage. And once you get up to EF5, that's basically complete destruction. The house was there, the tornado has destroyed it, and just swept everything away at that point, leaving just the concrete slab. So here's a real-world example. This is from the Mayfield, Kentucky tornado in December a few years ago. And tornadoes don't do the same damage throughout their entire area. So you've got the core of the tornado that travels through the center of the picture, and that's our highest end of damage. I mean, we just see piles of rubble where there were houses. So that was rated an EF4. And then you get progressively less damage as you go out from the center. So we've got an area of EF3 damage next to that, 2, 1, and then hardly any damage on the outside, and that was our EF0 area. So to rate tornadoes, we have to go out and look at the damage. We can't just look at a radar or look at pictures and say, okay, yeah, it was this. No, we have to go out and assess the damage, because not only does, how much destruction was there, what was damaged, but construction goes into that. Was everything constructed properly? Was the roof connected with hurricane clips or not? Because if your roof's not connected with the hurricane clips, tornado can easily just lift that right off, and then you get wall failure because of that. So construction methods and materials go into that damage rating as well. So other types of tornadoes, we kind of mentioned this earlier. Waterspout is just a tornado over water. These are associated with a thunderstorm, which is a rotating storm, or a fair weather waterspout, which is when you get cool air over warm water, typically late in summer, early fall. And you get that rising motion and it starts to spin. But regardless, if you see something, let us know. And then there's also land spouts. That's like a fair weather water spout. It's kind of the same process. You don't necessarily have to have a thunderstorm for those to occur. They're pretty rare in our area, but we can get them. One area of the country that gets a lot of these is eastern Colorado, the high plains of eastern Colorado. And these form a little differently. These start from the ground and go up into the cloud. But if you see them, report them nonetheless. We want to know about it. And there's also something called a cold air funnel. And this is a weak funnel that forms beneath showers or weak thunderstorms when you have very cold air aloft, like once we get into the fall. These don't reach the ground. They're harmless. They don't form tornadoes. You can let us know about them because we can put out a message and it says, these storms are producing cold air funnels, but they're not expected to touch the ground, shouldn't cause any damage, nothing to be alarmed about. But radar's not going to pick that up, so we need the spotter reports to be able to know that that's actually occurring. So let's say a tornado's coming, you have to take shelter. Where are you supposed to go? The best scenario is a most interior room on the lowest level of a sturdy structure. So you don't want to be upstairs in an attic or an upper level. You don't want to be in an outside room with windows. You want to try to get into a room with no windows in the center of a room. A lot of times that could be a bathroom. Climb into the tub. Cover your head. Protect yourself. That's going to be the best. Outside, there's really not a good place to be. You definitely don't want to go underneath a highway overpass. That's probably one of the worst places you could go because the air is going to get squeezed into that area. And once it gets squeezed, it accelerates. So the winds are actually stronger underneath a highway overpass. So not a good place to be. So when you're looking for shelter options, worst options are going to be a mobile home, a vehicle, that highway overpass. Gyms, large open rooms, auditoriums, not really the best place. You want to get into a well-built structure. If it's got a basement, awesome. Best option is going to be some sort of tornado shelter above or below the ground or some type of safe room that's developed. A lot of homes up here don't necessarily have basements. The water table is kind of high in a lot of areas. We have a lot of boggy areas, so you might not have that underground option. But places that aren't safe, under trees, RVs, mobile homes, cars, tents, large open rooms, not good places to be in a tornado. So in terms of tornadoes, we need reports of rotating wall clouds, funnel clouds, and tornadoes, including water spouts. And if you can't confirm it's a tornado versus a funnel cloud, that's okay. Call us, tell us what you see. If you hang up with us and then it comes out from behind some trees and you can tell it's on the ground, give us a call back. That's great. But one thing to remember, your safety is more important than a report. If you're in danger, take cover. Don't put yourself or others in danger to get us that report. Get in the shelter and then let us know once the danger is past. So that's the updraft features that we're looking for. Now let's talk about the downdraft features. Downdraft area is going to be where most of the hazards are. Lightning, heavy rain, hail, damaging winds. One thing to remember about lightning is it can strike anywhere near a storm. But most of those cloud to ground strikes occur in the downdraft region. So that's why we're going to talk about it now. One downdraft feature is a rain or a hail shaft. These are very common, and they're a clear indication of where that downdraft is located. They can be different colors, shapes, sizes, and sometimes they can be mistaken for tornadoes. If you get a very concentrated rain or hail shaft, it can look like a tornado touching the ground, but the key differentiation here is they're not going to be rotating. So it's very easy to get confused by these if they're very narrow and compact in size. Our second downdraft hazard is hail. And I'll also take a moment here to give out our next code word, which just so happens to be hail. So mark that down. We'll need that later on. So, how do you get hail? Well, you get warm, moist airs lifted through that updraft. As it rises above the freezing level, those droplets start to freeze, and then you get small hailstones. And then once they get high enough into the cloud, that updraft can't support it anymore. They become too heavy, so then they start falling back down through the downdraft. And as they fall, they'll hit other droplets and areas of moisture as it falls through the cloud. So it'll pick that up and it'll get bigger. And then if it hits that updraft again, then it starts going back up, and then that freezes. So you keep going through this cycle, and the hailstone gets larger and larger and larger. If you're able to sometime get a hailstone and you're able to cut it, you can see rings in the hailstone. And every one of those rings is one cycle in this process. Eventually, that hailstone will become too big for the updraft to support it. Gravity takes over, and then that falls to the ground. All thunderstorms produce some hail, but most of the time it's tiny and it melts before it reaches the ground. Hail can be extremely dangerous. They can cause injury to people that are not protected from the elements. If you're out camping, tent's not going to do anything for baseball-sized hail. That's going to come right through the tent. It can cause damage to vehicles, smashed windshields, dents, and it can cause damage to buildings, siding, roofing, windows. We had a supercell thunderstorm move across Pine County back in July of 2019. This was a time when there was construction along I-35, and this was a Friday, I believe. So you've got everybody from the Twin Cities heading up north to the cabins, heading up north for a weekend away, and they're stuck in this traffic as this giant supercell is coming, dropping baseball-sized hail with 65-mile-an-hour winds. There were numerous cars that just had their windshields shattered on the highway, and then that wind-blown hail basically peppered that house there in that photo, and all those black marks are points where hailstones hit the house, the wind-blown hail, and that can cause a lot of damage. So for hail to be considered severe, it has to be 1 inch in diameter. That's about the size of a quarter. And that's the threshold of damage. So that's when you're going to see the vehicle dents, maybe siding, roofing, break windows. Anything smaller than that doesn't usually cause damage, so that's not considered severe. 1 3/4 inches is about the size of a golf ball. You're definitely getting property damage at that point. 2 3/4 inch hail or larger, 2 3/4 inch hail is baseball size. That's destructive. You're going to get a lot of damage at that point. So how do you report hail? What we're looking for is hail reports a 1/2 inch size or larger. Smaller reports are fine too. If you've got pea-sized hail, let us know. That helps calibrate ourselves to what we're seeing on radar. If we know a storm's producing hail at what it looks like now, if we see it get stronger, then we know that it's probably producing larger hail at that point. When you do report, let us know the largest size. It's not all going to be uniform. If you've got a lot of pea-sized hail on the ground, but you've got some quarters mixed in there as well, let us know. Say, hey, I've got pea-sized hail covering the ground. There's a few quarters embedded in theirs too. That's awesome. That's what we want to know. If you don't have a ruler, compare it to a common size. Here's a chart on the right. Pea-sized hail, and then we move into coin-sized, pennies, nickels, quarters. Larger than that, we get into our sports balls, ping pong balls, golf balls, tennis balls, baseballs. Grapefruit at 4.5. You don't want to be anywhere near that. A lot of times we get reports of marble-sized hail. Please stop. Lose your marbles. Marbles are different sizes. We don't know what size you're talking about. And I think this is going to be a problem that fixes itself here, because I don't see a lot of kids playing with marbles anymore. I don't see them at the store. So maybe as we get into a new generation, we won't see those marble reports anymore. Something unique to our office, we have gotten reports of taconite pellet-sized hail. That opens up another whole can of worms, because different plants produce different sizes of taconite pellets. So we ask that you stick to the standard ones. Coins, balls, that kind of thing. And then downdraft hazard, another one, heavy rain flooding. Thunderstorms often produce flash flooding, which is rapid flooding that occurs in the next 6 hours, and it poses a threat to life and property. This is an event we had back in 2018 where we had thunderstorms just continually move across northwest Wisconsin, and it just ripped up the roads there, the rushing water over the roads. In the upper right, that's US 2 in Bayfield County. That is a very heavily traveled road. And that I think that's Fish Creek there. It originally was a culvert that you can see, but the culvert could not handle the volume of water that was running through there, and it scoured out everything on both sides. But most likely, the pavement was just suspended there over the water. It had eroded all the sub layer out, but the pavement was still hanging there. So if it was the middle of the night and you come up to that and you see, the road's still there, I'm fine. Well, as soon as you drive onto that pavement that's suspended there, it gives way. Now you're in those floodwaters floating downstream, and you're in a world of problems at that point. So that's why we say, especially at night, turn around, don't drown, because you don't know if the road's actually still there or not. But flash flooding typically happens due to wet and saturated soil or very heavy rainfall rates over a short period of time. Terrain plays into a lot of this as well, especially near Lake Superior. We've got some pretty drastic terrain changes, and especially in the Duluth area. The Duluth hillside is very prone to flash flooding because it's all rock. So if you get a heavy thunderstorm on top of the hill, that water's got to make it to Lake Superior, and it's going to get there in the shortest route possible. So that's why we have problems with flash flooding on the Duluth hillside. Flooding is the costliest and most common natural disaster in the United States, and it can happen anywhere. Rural, urban areas, North Shore, South Shore, everywhere. Most flood-related fatalities are vehicle-related. Never attempt to cross a flooded road. If you're camping and there's heavy rainfall, move that campsite away from streams if you're by one. If you're home, you've got a sump pump, a battery backup sump pump might be a good idea. In case the power goes out and you get heavy rainfall, you don't want that water building up in your basement. But again, most of those flood fatalities happen at night, so be especially cautious if you come across a flooded road at night. Turn around, don't drown. So what do we want to know when it comes to flooding? We want reports of unusual flooding, especially if the water is moving fast. If it's just standing water filling up the ditch on the side of a road, we don't necessarily need to know about that. If it's a low spot on the road that always fills up with water when it rains, that's not really important. But if you're sitting at home and you look outside and there's a river running down your street, your garbage can's floating away, yeah, we want to know about that. That's very unusual. That's what we want to know about. If you're out and you see a sign up that says road closed because it's flooding, don't assume we know about it. Hey, give us a call. Just because the city put up a barrier because the water's over the road, they might not have had a chance to call us and tell us. So just let us know. We'll say, even if we know about it, we'll say, hey, thanks for letting us know, and we'll go about our business. A lot of flooding happens overnight, and it is so hard for us to get reports overnight. So especially if you have a flooding report at night, let us know. Please don't go flood chasing. Don't put yourself and our first responders in danger. If you go out driving looking for flooding, you drive into a flooded area, you start floating downstream, now the first responders have to come out to try to rescue you. So just stay at home, keep yourself safe. It only takes 12 inches of fast-moving water wash away a small car. Only 6 inches to knock over an adult. So moving water is extremely powerful, and it's not something to be messed with. We get a lot of lightning in the downdraft area. One of the things we say is when thunder roars, go indoors. If you're outside, a sturdy house, a building, a car with a hard top roof, those are safe areas. The car kind of acts like a Faraday cage. It'll strike the car, and usually there's enough metal in the outside body of the car where it'll channel that around the passenger compartment and then down through the tires into the ground. Now, if it's like a ragtop Jeep, that's not the best place to be. You need that hard top there to disperse that charge around the passenger compartment. If there is lightning, stay inside for at least 30 minutes after the last you hear of the thunder. If there's a storm going on, you want to get to some sort of substantial structure. Sheds, pavilions, picnic shelters, porta potties, those aren't the best places to go. If you're inside, try not to use electronics that are connected to the wall. Don't be going under or near tall trees. If you're in the water, you want to get out, get away from windows. One thing that we've found out with lightning casualties is we'll have the most right before the storm is overhead and it starts raining, but then people see, okay, the rain stopped, I can go back outside now. No, there's actually a secondary peak at that point. The storm's moved away, it stopped raining, but that lightning can still be in the area for up to 30 minutes after a storm passes. So it's really important that you wait 30 minutes after a storm before you head back outside. Other thunderstorm safety, especially if you're out in the boundary waters, if you're outside, there's really not a safe place to protect yourself from lightning. Shelter can help, but if you don't have it, there are ways to reduce your risk. Try to pick a least risky option. Get off peaks, ridge tops, overhangs, cave entrances, isolated or tall trees, metal objects, bodies of water. Get to low spots away from trees. Short trees with uniform heights. That being at least twice the tree height away from tall trees. You really don't want to be the tallest object in an area because that's going to make you more of a target for lightning. If you're in a group, spread out. If one person gets struck, everybody's going to get struck if you're all clumped together. But if you spread out a bit, that can help mitigate that. And also, if somebody does get struck, there's probably going to be somebody around to get help. And our last downdraft hazard is damaging winds. Well, what is this? It's just rain-cooled air, which is denser than the environment, so it drops out of a thunderstorm, hits the ground, and then spreads out and causes damage. Most of the time, your strongest areas of damage are going to be in the direction of the storm motion. So if your storm's moving to the east, as those winds hit the ground and push out, the winds moving to the east are going to be the strongest. These damaging winds can be sporadic or they can be widespread. If it's more sporadic, we call that a microburst, or if it's widespread, that's a squall line or a derecho. Sometimes on the front of these lines of storms, as we get that damaging wind pushing out, or maybe not necessarily damaging wind, but the wind's pushing out in front of the storm, that's pushing the warm air up in front of it, as in the graphic we have there. And then we get that rolling motion there on the front of the storm. That's a roll cloud or a shelf cloud. The difference here is that the rotation in there is going to be on a horizontal axis. So it's going to be more like a rolling pin or a steamroller, as opposed to a tornadic circulation, which is going to be a vertical rotation, more like a barber pole. So that's something that's easily mistaken as tornadic rotation, but it's a different axis is what's important there. So ways to stay safe in thunderstorms with winds. Winds are the most common thing we see up here. This is a very real threat. And a lot of times, the strongest straight line wind events are going to be just as destructive, if not more, than the tornadoes we get up here. So safest place to take shelter is in a sturdy building away from windows. If you're in a vehicle, try to get that parked away from trees or power lines. A tent is not a great place to be. And especially if you're under a tree, it can be deadly. You get a branch that breaks off, falls down on the tent, that's falling on top of you. Especially if we get heavy rainfall associated with these damaging wind events. As that ground becomes saturated, the wind comes and hits the upper parts of the trees where all your leaves are, and it uproots the whole tree and tips over, which is what we had here in Superior back in 2020. So not just whole branches, the entire tree can come down too. So when it comes to reporting wind damage, we want details. If it's trees, was it a healthy tree? Was it a dead tree? How many trees? How big was the tree? What happened? Was it uprooted? Was it completely snapped off at the base, or is it just a few branches that are down? If it's building damage, let us know how severe it was. It was just a few shingles that were blown away? Was the whole roof peeled off? Was outdoor furniture tossed? Was a shed blown over? That kind of thing. Just let us know of any kind of property damage. If you have to call your insurance company to report it, we want to know. That's important for us. Estimating wind speed is a very, very difficult activity. So we ask that you try not to estimate wind speed. But if you've got a backyard weather station or you have a handheld anemometer and you can give us a reading off of there, awesome. That's going to help us. And for wind damage, pictures and videos are very helpful as well. You can send those to us via email, which we'll give out here in a little bit, or send it to our office through Facebook message. But these are all the wind reports that we got last year, whether it be wind damage report or wind gust measurement. So as you can see, this is a lot of what we get up here. So as a little bit of an exercise here, we've got these two pictures. And, thunderstorm rolled over the area, and this is the damage that was caused. We've got pretty widespread tree damage in both pictures. Was it a tornado? Was it straight line winds? Well, actually, the picture on the left was tornado. We do see a little bit of convergent damage there in the photo. Let me turn on my handy dandy laser pointer. You see the trees over here kind of laid out in this direction. Some of them are laid out in this direction. So it looks like a tornado probably went, from the bottom right corner up to the upper left corner and went through here. We see that convergent damage pattern. Now over here on the right, all these trees are pretty much laid down in the same direction. So that's more indicative of straight line wind damage. Especially in our area with all the forested areas, we really need to get up in an aircraft to be able to see. Or a lot of times we can use high resolution satellite imagery now to pick out damage paths through forests. But from the ground, it might look like it was a tornado. But like I said, the strongest straight line wind events can produce damage just as bad, if not worse, than a tornado. And we talked about this a little earlier with those shelf clouds. These are usually at the front part of a storm. They're, if somebody takes a picture of a storm, this is most likely what they're taking a picture of. They look pretty cool. It's not indicative of severe weather at all. But it could mean the gust front is about to hit you. You might about to be pelted with 40 to 50 mile per hour winds. I talked about this a little earlier. You get that rising motion at the front of the gust front, which causes that shelf to form. It might form that roll cloud with that horizontal rotation. It's not a tornado. A lot of times you'll see lots of disorganized motion. I like to describe it as like boiling water. It looks scary, but a tornado is not going to form in those areas. They look pretty cool, but you don't need to report them. But if you want to take a picture and send it to us, awesome. we can put it in one of our presentations in the future because they are really cool to look at. Another feature in the downdraft area is what's called the Scud cloud. Scud is actually an acronym for stratocumulus under deck. Well, what does that mean? It's just a general term for low, ragged cloud fragments. They're not rotating usually. If they are rotating, they're just caught up in the overall flow going on under the cloud, but they themselves are not rotating. And they typically move away from the rain-free base. So if you've got a developing wall cloud, you'll have a lot of cloud fragments that are going to be moving upward, rotating, moving towards the rain-free base. But these Scud clouds are usually moving away from the base. And they can't look scary, so that's why we call them scary-looking clouds sometimes. And in our examples here, gosh, that one in the lower right, that certainly looks like a funnel cloud. But based on where you're positioned, kind of hard to tell from the photograph, but we can see a lot of rain going on behind this. So this was in the shelf cloud area. That's not a tornado. It's not rotating. Just a Scud cloud. So start to wrap up everything we've learned here. Let's have so many arrows show up on the screen. So first thing we're going to do is find the updraft. How do we do that? Well, we got to find the rain-free base and any areas of upward motion. Once we find that, then we find the downdraft area. Maybe. There's our downdraft area. So typically, the downdraft is going to be in front of the updraft if you're positioned in the right place. So the updraft follows the downdraft. So if you find the downdraft area, you find the updraft area, that can help you determine the storm motion in addition to just watching it. So in our example here, we're looking at the storm. It's moving basically left to right. So we know where our updraft is. We know where our downdraft is. We found the rain-free base under the updraft, the wall cloud, any potential tornado area. That's our inflow area. And then in the downdraft area, that's where we're going to have the heavy rain, hail, any potential shelf cloud, maybe a gust front, maybe a roll cloud. That's all the front of the storm. Now, as you see in the graphic here, there is something called the rear flank downdraft. That's a little more of an advanced topic. We cover that in our advanced class, but that's another area of strong winds that come out of the storm. And that can play a role in tornado development as well. But it's a little more advanced, and if you want more information about that, tune into one of our advanced spotter classes coming up. All right, now we know what we're looking at. How do you report it? A lot of different ways to do that. But first, want to hit those safety things up again. Hit that safety strong once again here. We want you to be safe. Don't take unnecessary risks. If you're out storm spotting, be sure you know the following. What kind of hazards am I expecting? Lightning, hail, flooding? Is there a watch or warning in effect? You want to know your location. Where are you relative to the storm? Is it moving towards you? Is it moving away from you? And what is your safety plan to take shelter? If you're out spotting and you're spotting on a dead end road, if you need to get to shelter, do you have to drive right into the storm to get to your shelter? Or does that road lead away from the storm and allow you to get to shelter? Storm evolution can be unpredictable. The threats can change. A new storm can develop. A storm can turn. It can speed up. It can slow down. So don't just become fixated on one feature. Don't get tunnel vision and just keep focusing on the wall cloud, because a lot of times supercells especially can be what's called cyclic, and they develop a new area of rotation. That could be to the left, it could be to the right, depending on your orientation. It can also be right above you. So I like to say, keep your head on a swivel. Always be looking around, see how things are changing, making sure that if that area that you're in was safe, is it still safe? And again, we do not encourage storm chasing. It is very dangerous, and it is a very advanced skill. We're not teaching it here. We're teaching spotting skills. And most people, they spot from home or wherever they're at. And spotting itself can be dangerous, especially at night. The best thing to do in this case is just stay at home, watch from out the window. Once it gets dark outside, you can't see anything. And that's pretty important when it comes to storm spotting. Again, lightning can happen without warning far away from storms, and flash flooding can occur after the storm passes, so we don't go out looking for damage at night. One of the problems with trying to spot at night is you're relying on lightning or other lights to be able to identify these features. Well, depending on where the lightning is or how often it is, it can be a strobe light effect or it's lighting different parts of the storm. That can, start to play tricks with your eyes. Watching here in this video, we see some sort of communications tower in the middle. It looks like on the right side there's something coming down out of the storm towards the ground. What's going on? Well, now I don't see it anymore. Very difficult to see what's going on. Well, that looked interesting. So the whole point of this video is to show how difficult it is to try to see things. And in a couple seconds here, we'll slow it down and freeze it. There's a tornado just to the left of the tower at this point. But you're going to be second guessing yourself on every lightning strike. What did I see? What was that? So, very, very difficult. Keeping with the safety theme here, if you're out on the water, that's not a good place to be. We don't issue any sort of specific warnings or advisories for lightning, but just remember, all thunderstorms produce lightning. And a lightning strike to a vessel can be pretty bad, especially if it starts a fire or you lose your electronics, you lose your radio, can't start the motor. So if you're out on the water and there's a chance for storms on the day, keep that in the back of your mind. Make sure you have a plan. If you see a storm starting to come up, make sure you're close enough you can get to shore and get out of the water, because lightning can strike the water and expand out from there. So the lightning can strike away from you, but that current still comes up to your boat, because water is a very effective at carrying that charge. So, in terms of reporting, what do we want to know? Well, any possible tornado signs. That's going to be rotating wall clouds, funnel clouds, and tornadoes and waterspouts. For severe thunderstorms, we want hail. We want the largest hail size. We want wind damage. Let us know. Was it, a tree damage, a home damage, something else? Let us know what the damage was, and details. How big was the tree? Was it healthy? Those kind of things. We want measured wind gusts. Please don't estimate it. Give us those measured wind speeds if you've got a home weather station or a handheld anemometer. And then in terms of precipitation, we're looking for any unusual flooding, especially if the water is fast moving. Sometimes we want rainfall measurements. We'll ask for those on social media, especially if it's over an inch. And during the winter, we want those kind of precipitation measurements too. That's mainly an inch of snow or more, but we'll take lesser reports than that. We don't need reports of shelf clouds, and we don't need reports of lightning, unless it causes damage or injury. So if lightning strikes a home and starts a fire, yeah, we want to know about that. But call 911 first, and then let us know. So before I give the reporting instructions here, I'll give you your last code word. That last code word is going to be radar. Radar. So, you know what you see. You're ready to make the report. How do you get a hold of us? Give us a phone call. 1-800-685-8612. You call this number, every phone on the operations floor is going to ring, and somebody's going to answer it. We want to talk to you. We want to ask you questions. We want to know what you're seeing. So calling us is the best option. But with this special super secret spotter phone number, please only call it to give us reports. If you've got a weather question, don't call us in the middle of severe weather, but use our public phone line, get in through our phone tree that way. Because if we see this line light up, we're going to be expecting a storm report. Send us a comment or a message on Facebook. A lot of times we'll put out a post asking for storm reports. If you don't feel comfortable giving your location, send us a message instead. We're the only people that are going to see that. Twitter, you can reply to us, you can mention us, and we'll see the report. Email, nws.duluth@noaa.gov. That's going to go to everybody. That's especially useful for pictures. We've got an online report form, which we'll talk about here in a moment. And amateur radio operator. If you are a ham operator, there are multiple nets across the area that you might be able to report through. Talk to your local club or let us know if you have any questions. We can direct you to it's the Arrowhead Skywarn response team, I think is what it is. And they're collecting those reports and then they're letting us know what those reports are. But phone is going to be best for urgent reports. Social media or email is good for less urgent reports, especially if you have photos. And the online report form is a great way for all reports. If you do use the online report form, there's an option at the end to give us a phone number or email address. Please put that in there. We might have follow-up questions for you, and we don't know how to get in touch with you otherwise if you don't send us that. But the nice thing about that online report form is that feeds right into the piece of software we use to enter storm reports. So that's going to save us a little time too. So when you call in the report, we're looking for 4 main things. We're looking for the time, the location, the condition, and the source. For the time, when did it happen? It's happening right now? Did it happen 20 minutes ago? 2 days ago? That's important. Location, where did it happen? If you don't have an exact location, if you don't have an address of where you're located, give us a nearby landmark or a road intersection. I'm at the corner of Miller Trunk and Levake Road. We know where that is. Use a nearby landmark or nearby town. I'm 3 miles west of Cotton. Okay, we know where that is. Condition, what are you reporting? Hail, wind damage, what happened? And finally, the source, who are you? And let us know you're a trained spotter. So, taking a look at a couple examples here. Hi, this is Joe. Okay, we know who you are. I'm a spotter. Okay, great. In Duluth, and I'm down in Canal Park next to the lift bridge. There is no doubt about where you are located there. That's about as precise as you can get. We've got quarter-sized hail. Okay, that's the condition. Falling right now. That's the time. Maybe some bigger stones too. I'll send you a picture on Twitter. Awesome report. Next example. Hi, this is a spotter. My name is Sarah. Okay, we know who you are. That's our source. I'm calling to report wind damage that just happened. We just had about a half dozen tall pine trees knocked down in our cabin on Whiteface Reservoir. The address is, gave us a location, you gave us the condition, and you gave us the time. Another great report. Late reports are okay. If you get back to your cabin or you come back from out of town and there's a tree across your driveway, let us know. Even if it's a couple days after it would have happened, let us know. Sometimes that delayed report is the report we're waiting for to be able to verify a warning. We really like pictures and videos of severe weather, and we can use them on our website, especially if we do an event review, or we can use it in training like this with your permission. We're always going to ask for your permission if we can use it for that. And you can send those on later too. And it's okay if you're not exactly sure what you're looking at. You give us a call, we can talk you through it. We can figure out what you're looking at. And don't forget that location part. I can't tell you how many times people call us and say, oh, I've got hail here. Or I've got 2 inches of snow at my location. Great. Where are you located? I got to know that. I don't know where you're at. So location is very important. Here's that online reporting tool. Unfortunately, you can't click on it in a video, but it's inws.nsep.noaa.gov/report. When you get there, the first screen, you're going to select what you're wanting to report. Next screen, you put in your time. You provide us the details of what happened. If you've got a measured wind speed, you can put it in there. Next screen gives us your location. If you're on a cell phone or on a lot of computers, it can pull your address right from that. Otherwise, you can drop a point on the map, or you can just type in your address. And then finally, on that last step, you see a review of your report, and then there's that box down below, just above the red text, that you can put in additional information. Give us your name, number, email address. So if we have any questions, we can call you. And then if you've got a smartphone, you should be able to scan that QR code there in the bottom left, and that'll open up this reporting page as well. So you can bookmark it, because I'm not going to remember that link. That's a lot of letters. Another option to report is the mPING app. This is available on iPhone and Android system. It is a free app from NOAA to report precipitation type, but not amounts. This is especially good for winter precip types. It can really help us find where that rain-snow line is, or if there's any sleet or freezing rain occurring. You can send hail reports with this, best for 1-inch hail or smaller. Unfortunately, while it does allow you to report other things like wind damage or flooding or tornado, we ask that you don't. mPING is completely anonymous. We don't know who reported it. So if we have a question, we don't have a way to contact you to ask any follow-up questions. We had an instance a couple years ago, somebody gave us a flooding report, and we called the county dispatch. They hadn't heard anything. We called the EM. They hadn't heard anything, and it was a couple hours before they were able to get out there and say, oh, yeah, there is some flooding here. We could have found that out a lot sooner had we known who sent us the report and could contact them. But if it's something you're interested in, there's a QR code for it. You can download that. It's also integrated into some of the radar apps that are out there, so you can send that report right through the app. But mainly winter precip types or hail sizes. If you're not familiar with the CoCoRaHS program, it is a great way to report rain and snow on a regular basis. Well, what does CoCoRaHS stand for? It's the Community Collaborative Rain, Hail, and Snow Network. It is a NOAA-supported nonprofit network of volunteer observers, and the only requirement to join is the purchase of a standard rain gauge. About $30 to $40. They're made right here in Minnesota. You install that on your property, and then you report what you get. Daily reporting is encouraged, but it's not required. You can just report when you want. If you have a cabin and you want to report it while you're at your cabin, great. The rest of the time you report from home. That's awesome. These reports are automatically pulled into our software. You don't need to call us to report rain and snow amounts. If you're interested in joining, CoCoRaHS.org is the place to go, or get in touch with Ketzel here at our office. She loves CoCoRaHS, and she'd love to talk to you about it if you have any questions. We have a lot of observers across our area. We do have some holes. We do realize there's a lot of open area, a lot of bogs, a lot of wilderness areas. But if you happen to be in one of these holes, or if you're not, we'd still love to see your reports. We've got a big hole there up in northern Lake County into western Cook County, and as much as we try, the moose are just not reliable observers. So we got to get some better observers up there. So, a lot of different ways to get in contact with us. At the end of the day, use what's best for you. If you've got urgent reports of severe weather, give us a phone call or use that online report form. If you've got urgent reports of sub-severe weather, small hail, minor flooding, maybe use the mPING app, use the online report form, or give us a phone call or tag us on social media. For delayed reports, that online report form or social media email is going to be the best. Phone call works well as well. And any rain or snow amounts, CoCoRaHS program is going to be the best avenue for that, but you can also use the report form, social media email, or a phone call. If you only remember one thing, phone calls. give us a call. We love talking to our spotters. Getting to the end here, let's wrap things up. Severe weather doesn't happen unexpectedly. Be prepared. Follow our office on social media or your local office if you're not in our area, and check your local website to know what the severe weather risk is for the coming days. The Hazardous Weather Outlook is a great place to find that. Play on the NOAA Weather Radio or find it on our website. Know the difference between a watch and a warning, and tell a friend. Remember, a watch, severe weather is possible soon, be ready. Warning, severe weather is here, take cover now. Have a plan for shelter when severe weather strikes. All thunderstorms produce dangerous cloud-to-ground lightning. When thunder roars, head indoors. Safest shelter from a tornado or severe thunderstorm is in an interior room in the lowest level of a sturdy building. Practice your tornado safety plan with your family. And flash flooding kills. If you encounter a flooded road, remember, turn around, don't drown. Never cross a flooded road, especially at night. And again, watch versus warning. Your watch, our ingredients are in place. Warning, it's here. It's happening. And again, weather spotters are crucial to what we do here at the National Weather Service. Your report could help save a life. We need your reports to help issue accurate and timely warnings. And while we want to get those reports in a timely manner, please never compromise your own safety to get us those reports. Take shelter, and when it's safe, then give us that report. So that'll wrap things up for us. Thank you if you've made it through this far. If you want to register to be a spotter, head over to our website, weather.gov/DLH/Skywarn, which you're already there if you're watching this video. And there'll be a link there to access our form. We ask that all of our spotters retake spotter training every 3 to 4 years. You may receive a couple emails through us out the year asking for a report, advertising spotter training, or asking you to confirm your information. So, congratulations, you are now a Skywarn spotter. 3 things to do right now. Save our super secret spotter phone number. Program it into your phone so you always have it. 1-800-685-8612. Again, this is only for our office. If you're watching this from outside our forecast area, contact your local office and get that phone number from them. Bookmark our online storm report form. There's the link again, or a QR code there on the left to get that. And be sure to follow us or your local office on social media. We're on both Facebook and Twitter. If you have any questions or comments about this presentation, let me know. There's my email address. Be more than happy to talk to you about how we can change things or improve it to make things better. And that's our training. Thanks for stopping by, and good luck out there if you see any storms. And remember, phone call. We always love talking to you. Have a great day.